All right, welcome back. This is going to be part two of the section 13.1 notes. So if you haven't watched part one yet, you need to do that first. Part one is where we talked about something called the distance formula, which is right here. It's how we could find the distance between 2 points on a coordinate plane. We just take the change in x and we square it, and the change in y and we square it. Here we're talking about the coordinates, the ordered pairs for the 2 points. So we square the change in x, we square the change in y, we add those things together, and then we take the square root of that. And we talked in the last video about how that's basically just the Pythagorean theorem kind of solved for d, if you will, with d isolated, so square root on the other side. So let's look at how that applies to circles, right? It says, how can the distance formula be used to determine the equation of the circle in the graph below? Now, when we talk about equations of things on a graph, equations of lines, equations of circles, in Algebra 2 you'll learn about equations of things like ellipses and parabolas and hyperbolas. Equations of items or objects on a coordinate plane is just a description of how all the points for that fit together, right? A circle is an infinite number of points. This circle right here has an infinite number of points. And each one of those points is a coordinate, like F right here. F has a coordinate, has an ordered pair that describes its location. It has an X and a Y that describes its location. Now this F looks like it's somewhere, it looks like it's about 6 point something, comma 8 point something is where the general, the general location of this F is. But what I'm concerned about is how do all these points, all these x's and y's that would be on this circle, how do they relate to one another? What's the formula that tells me the relationship between the x and the y? Because if I can graph something like this, like a circle, or a line, like we'll do later on in this chapter, there is some relationship between the x's and the y's. And so we're going to look at how does the distance formula help us figure out this relationship between this x, this y, and this center and this radius, right? All those things play into the equation, or all these different points that would be on that circle. So let's think about this for a second. I know that I have a center of a circle and I have a radius of 4. And the definition of a circle is all the points that are a certain distance away, the radius away, from a center point. So in this case our center point is 4, 5, and our radius is 4. So all of these points are 4 units away from 4, 5. Well, what does that mean, and what does that have to do with the distance formula? Well, if you think about the distance formula being the square root of the change in x squared plus the change in y squared, or another way of thinking of it is it's the square root of x2 minus x1 squared plus y2 minus y1 squared. And if we start thinking about the fact that these are all 4 units, so there's a distance of 4 for this point x away from this point 4, 5. So in other words, if I take the x right here for f and I subtract 4 and square it, right? That's the difference between this x value and the x value of the center of the circle, which is 4. And I say plus y2, which I'm just going to call plain old y, or the generic y coordinate of my point that's on the circle, minus the y coordinate for the center, 5, and square it, that will always equal 4. So the distance between x, y and 4, 5 will always be 4, no matter where I pick that x, y. If this is point G, that's my x, y, or this point over here, H, let's say that's my x, y. No matter what point I pick, if I put that, that value in for the x and the y, that ordered pair in for the x and y in this little equation, it should end up being true, because the distance between that x and that y and 4, 5 will always be 4. So now this is basically a description of the relationship between these points on the circle and this center point 4, 5. But it looks kind of ugly because it's got this big square root in it. So what I'm going to do is I'm going to square both sides. I'm going to take this side and I'm going to square it, and I'm going to take the 4 and I'm going to square it. And I'm going to flip it around as well. So this, I'm going to kind of change the two sides of the equation. So when I square the square root, they kind of cancel each other out. And it leaves me x minus 4 squared plus y minus 5 squared equals 4 squared, which is 16. So this looks a little bit nicer than what I had before. And this right here, this would be an equation that describes all the points that are on this circle, all the points that are 4 units away from a point 4 comma 5. So all these points fit into this equation right here. So that takes us to theorem 13-2. An equation with a center at h comma k. So hk in this case would be like 4 comma 5, and a radius of r. So what does that equation end up looking like? Well, if I kind of look up here to what I determined to be the equation of this circle, I notice that I have x minus 4 squared plus y minus 5 squared equals 16. And in that case, h comma k for our picture here was 4 comma 5, and r was 4. And so what I noticed is I took my x and I subtracted the value for h and I squared it, plus the y, subtracting the value of y in this for the center of my circle, and I squared it, and that equaled the radius squared, because 16 is 4 squared, right? 16 is 4 squared. So x minus h squared plus y, oops, that shouldn't be a 5, so let me go back up here a second. This should be y minus k squared, sorry about that guys. X minus h squared plus y minus k squared equals r squared. That's the general equation of a circle. So how can we put that to use? All right, so what does this mean for us? What kind of problems will we be working on? Well, in example 2, it asks us to find the center and the radius of a circle that has an equation x minus 8 squared plus y minus 7 squared equals 64. So I look at this equation and I notice I have my my little x parentheses right here and my y parentheses right here, and it equals 64. So according to what I just learned in theorem 13-2, if I look at the numbers that are subtracted from x and y, those are going to give me an idea about the center of my circle, right? The center of my circle will be an ordered pair where this first number is the thing that's subtracted from x. Well, that would be negative 8. Well, wait a minute. That would be positive 8, right? Because it says x minus h. So what is subtracted from x? It would be 8. So our center is an x coordinate of 8, and the y coordinate would be 7, because 7 is the number that is being subtracted from y. So the center of my circle is 8 comma 7. Now the radius can be found by looking at what this side is equal to. It's equal to 64. That is r squared, right? R squared is equal to 64. So r would be the square root of 64, which is 8. So this circle would have a center at 8 comma 7 and a radius of 8. What we can also do with this information from theorem 13-2 is we can write equations of circles if we know where their center is and what their radius is going to be, right? This circle is going to have a center at 0 comma negative 3, and it's going to have a radius of 5 root 2. So what I do is I think about that x minus h squared plus y minus k squared equals r squared, and I fit these three numbers into this equation. The 0 is going to be my h, negative 3 is going to be my k, and 5 root 2 is going to be my r. So I say it's x minus 0 squared plus y minus negative 3 squared equals 5 square root 2 squared. But I can clean this up quite a bit actually. There's a lot I can do to make this look a little bit nicer. Starting right here. X minus 0, if I'm subtracting 0 from x, it really is the same thing as just having an x, right? So x minus 0 squared could just be written as x squared. It means the same thing. Now over here I have y minus a negative 3. That looks kind of ugly. Minus negative, it just doesn't quite look right. So thankfully what we can do is we can make it y plus positive 3. And that looks a little bit better. Y plus 3 squared. Now 5 root 2 squared, remember 5 root 2 squared means 5 root 2 times 5 root 2, which means 5 times 5 times square root 2 times square root 2. So that's a 25 times 2, because square root 2 times square root 2 just gives me 2. And that would be 50. So that's my last part of the equation. So this circle with a center at 0, negative 3, and radius of 5 root 2 would have an equation of x squared plus y plus 3 quantity squared equals 50. Okay, folks, that's it for section 13-1. We learned about the distance formula, and we learned about the general equation of a circle. So good luck with the homework, and we'll see you in the next video.